Okay, let's get started. We're going to talk about the thousands.
Sorry, no, I'll do it.
I mean, we're both coming in.
Oh, sorry, just to give the context. So in the beginning, you'll start by explaining how the OpenID for vertical presentation product will work itself, the first part. And second part, we'll dive into the current thinking, how that can be used over the browser API. So when we say simple mode, it's basically where wallet and the verifier are talking directly through the browser primitives. And just to explain how we designed it, why we designed it when browser API was not around, and then talk about like now that we have this browser API coming up, like how does that look like? How does it be used with the browser API? So just like in your mental model, just please differentiate like those two things. Yeah. Okay.
So the open-ID variable potential scope. We're working towards the third implement structure analysis, another stable version of Stripe already with the second last year's sometime. Designed for high privacy, hopefully easy to use for developers, various security levels, we'll do lots of authentication if you need it, different user experiences, same device across device, and that's even aside from if you're using the browser API, which normally the kind of customized stuff. Presentation of multiple identities is supported, potentially with the browser API as well as long as they're in the same wallet. Various different wallet deployment models supported. Backend or web wallet. You might mention a little bit from screen. Right, yeah.
So yeah, so the browser API we saw, it was one credential per request, but with when you're talking directly, there are a lot of use cases where like I'm trying to it's a real use case in Europe right now. For example, I'm trying to open a bank account. I want to present the digital government ID. I need to present the tax ID, digital tax ID, and the proof of my address, which are all different issuers, so that's a different credential. So that's kind of pulling up that.
So in the third implemented structure, there's going to be a new capability for the wallet to negotiate capability with the verifier. Like not, so that's sort of the solutions to when we need that. And we'll talk about the browser API lately.
And just to give context, because I got a question after yesterday's session, for those familiar kind of with OAuth, in terms of roles, the verifier is acting as a relying party in the OAuth terms, and wallet is what usually is kind of a serialization server in OAuth, but as you can see, if you have a native app, it's not a serialization server, right? So I think that's kind of the mental model in terms of roles, but that heavily impacts the design. So we started with those learnings from OAuth world, but what we have here is heavily influenced by the limitations of the wallet being the native app, like in like majority of the cases, right now.
That's talking specifically about presentation. Obviously, when you do issuance, the wallet is actually acting as
Exactly.
the client, so it switches role depending on which of the browser API lately. And we've also got an open discussion about optimizing and replacing the query language as a query language. In that discussion now.
And again, to set the context, so today we'll focus on talking about how using Open for VP request, the whole request over the browser API looks like. Inside that request, the verifier is telling the wallet, this is the credentials I want from you. Like this is, maybe the claims, maybe the format, whatnot. And that part is separate conversation. So like that, we're planning to dig into tomorrow. So if you're interested, let's chat tomorrow.
The browser API that we're going to show is very much a work in progress. There's a lot still open for discussion.
We're making progress. Where's Hisham?
So quick example of the same device presentation. User starts to verify website, to invite wallet, telling the user what kind of credential it wants and so on. The wallet authenticates the user, asks if they want to share the credential, assuming the browser has one, and then redirect back to the verifier. And again, it's a fairly standard flow. Fine here, essentially authorization server, back to the old client. Using some of this standard mechanisms, but augmented a little bit in these cases. And cross-device, so this is cross-device without using the browser API. So again, the same flow, but you present a QR code on the verifier website, you scan that in your wallet with the device camera, potentially a PIN number that's actually used to secure the credentials. So that's how we're kind of dealing with not being able to access Bluetooth to do proximity checks, so trying to check that the user's not being attacked. Same consent screen, and again, a redirect back to the verifier, but this redirect obviously happens on the mobile device, potentially not. That's back on the desktop there. So you share there, and then the verifier has the ability to update where you're interacting on the desktop once you stop the stuff mobile.
And I think it's kind of fascinating when you think about it. Even with the browser API, the UX wouldn't change, right? Kind of. It's just that this part of QR code becomes much more secure.
And it's provided by a different party.
And you have a small pop-up here, but
Yeah, I mean, in the case of a traditional OpenID for VP, it's being rendered by the relying party or the verifier. And it typically offers two options, right? Deep link, direct redirect, and the QR code. In case of the browser API, it's provided by the operating system, which makes it even much easier to integrate for verifiers.
And the only thing you get on the other side on the scan device is the selector that we saw, right? So it's kind of like the platform mediates the connection, but to Christina's point, the UX is very much the same.
Well, but for this work, I don't know if it's good to interject here, but I do feel like there's optimizations you can make if you're within the same ecosystem. So Chrome on desktop to Android maybe an easier communication. If you need to QR code where you go from Google to Apple. Yeah. But if you're saying within Google, then you may not need.
Oh, so you're saying using the link to capture devices without even having.
If you're logged in to your Google account in Google Chrome on desktop, and you're also logged in to your Google account on Android, then you already know that by now.
So yeah, basic story, it can be better.
Yeah.
let's take it offline. I'm not sure I agree. Let's take it offline.
Some flow charts, same device, browser, verifier acting as a OAuth client, wallet acting as an authorization server, verifier launches a pretty standard looking OAuth authorization request, client ID, nonce, redirect URI, presentation definition, which is presentation exchange, state value. So that will end up launching the wallet because this is the same device flow. So custom URL scheme or potentially just a direct link if the verifier knows what wallet. Wallet authenticates the verifier, authenticates the user here, and then creates the response. The response is set up by the standard OAuth redirect flow. You get a VP token instead of an access token or ID token. The presentation submission response, and then verifier validates it. So cross-device flow, and this particular one, the response is sent via HTTP post. So in this, again, this isn't using the browser API, so the verifier has to manually create a QR code with the authorization request in it, essentially. So the same thing with client ID state nonce as we had on the last one. The user scans the QR code in the wallet or on the device camera. Wallet does the same step of authenticating the verifier, doing the user consent, creating the presentation, and then there's what we call a direct post response here, which is instead of redirecting via the browser, because we're cross devices here, you get a direct post from the wallet to the verifier's backend, essentially, that contains the VP token and that response. And then so verifier then retrieves that from its backend, does this usual validation.
Yeah, so if I may, as a bit of context, redirect, response, and redirect, right? But basically, when we started working on the credentials, the big use case was I'm interacting with the line party on the, laptop, but I have a credential like on my phone. So that's where like how do you can't cross boundary of devices using redirect. So that's where this direct post came in. But then the feedback was the same device is more secure because you have a session binding here, right? Um, but then if you're returning the credential in the redirect because of size limitations of the browser, you can like the feedback was I think max one credential if you're especially using disclosure or whatnot. So that's why there's a combined mode where and that's because very hard to have a backend, but basically response gets sent in the post, which is step 7. But there's also a redirect from the wallet to the verifier. So if the verifier does the session binding, there's no phishing possible. And just to put in context, the phishing that we talk about in the cross device is where attacker just starts a session with the verifier. So it starts a session for the Joseph, for example. I steal that request, display it to
Tobias, for example.
to Tobias. Tobias scans it, and so the verifier first. So as an attacker, I managed to log into Tobias Joseph's session using credentials. So that's because as a verifier, like I don't know that the response returning belongs to the same session request was sent to. So that's where they see how the previous demo we saw in the previous session, like there was a big motivation to help secure that cross-device flow.
And there are ways to mitigate non-coding BP, like you can freshly rotate these QR codes and try and aggressively sort of rotate them so that the time that an attacker has to actually construct context, get someone else to scan it and fish them is really reduced. And that can reduce the risk. But fundamentally, in order the CTAP2 kind of demo and the Bluetooth proximity check is a much more robust way to sort of solve that credential phishing. Obviously requires the cloud browser involved in what we're seeing now.
So some actual example requests. So presentation request from the verifier to the wallet looks kind of like a authorization endpoint call, client ID, redirect URI, and then presentation definition saying what credential or credentials are actually wanted, what properties they need to have. So that's an example of the contents of the presentation definition parameter. This one's asking for a mobile driving license.
Yeah, I find it fascinating how ISO actually profiled presentation definition to make it work with MDocs. So that's what I meant. Because this is not JSON pass, right? They literally said like with the array of strings, the first string has to be a namespace and the second string has to be the claim name. So it kind of becomes the like absolute matching.
So presentation response, again, this is from the wallet to the verifier. The default mode is a standard looking OAuth redirect. You're getting sent to the redirect URI, presentation submission, BP token. Presentation submission just tells you what credential you are actually getting back compared to your request, and you get the BP token. This would obviously be an MDoc thing because it's an MDL, but that's just a decoded form.
But the response could also contain multiple presentations that match the request conditions.
All right, that was a standard how it looks like. From now on, we'll cover first the new response URI method post, and after that, we'll dive into the browser again. And this is relevant, but basically, the problem we face is in OAuth, what usually happens is when the client is talking to the authorization server, the trust relationship is already established, right? That happens kind of out of bounds. The client already has a client ID, it already knows the metadata of the authorization server knows the parameters of the line party, right? In this wallet ecosystem, we can't assume that because there's a huge number of verifiers, like more than 5 wallets is already there. So like how do we make that exchange of capabilities of metadata was kind of one of the big questions. And what we noticed implementers doing was send the request by reference. The first QR code or the first request is only the request URI, and then wallet gets it. wallet sends the GET call to the verifier's endpoint to obtain the actual request object. And when the wallet was sending the GET call, wallet was kind of abusing the header to communicate wallet's capabilities, right? So the verifier gets the capabilities, and so we can tailor that request object was generating, which is a bit of a abuse, but it is a problem. So just partially to solve that, we introduced this new response URI method proposed, and you can get when wallet's obtaining that request object from the verifier's endpoint, it's not doing the GET, it's doing a legit post where it can communicate wallet's capabilities. And also providing wallet provided nonce to secure to prevent the replay of the request object. So that's basically the nutshell.
May I add?
Yeah, of course.
And it not only provides the wallet nonce, it can also provide the encryption key. So the actual authorization request could be encrypted.
Speak up.
Okay, I'm trying again. Sorry. Sorry, Pedro. So a third feature that this allows is to encrypt the actual request. So that's not possible with the standard flows, but with that, the wallet can provide an encryption key, and the verifier can then not only sign but also encrypt the request if that is deemed necessary, because there is PII in the request. We had a conversation about it yesterday, so there might be, especially if you have subsequent requests for credentials, there might be PII in that request, and you might want to encrypt that. So that's why we also have that feature now.
Yeah, and it's an open question about exactly how this might fit into the browser API version at all.
We will see.
Yeah, thank you for clarifying that. Since it's not set to be in the browser API.
Yeah, no, so this is separate. I'm just
We will come to the browser.
it's a good transition though, because there was a problem to get all the things that is partially explained. So yeah, they knew it. Basically, if you're trying to do this new mode, all you have to do is to add this new parameter request URI mode, set it to post. Just to give you an idea, so verifier sends the request to the wallet through the browser, which contains the request URI method post. Wallet checks this first original request and then posts its capabilities, the metadata with the wallet provided nonce, maybe the encryption public key to the verifier. Verifier tailors this request to what it now knows what in process for sure, returns the full request objects, which is signed, potentially encrypted, and will just indicate that and flow continues as usual. So if you're familiar with jar RSA 9101, basically this get changes to post is the biggest change.
And there is also a graceful fallback. So for those wallets that do not support the new mechanism, they will fall back to the get automatically, because the new parameter, how's it called? The request URI method, if that is ignored by the wallet, it automatically falls back to get. So that is it's kind of the strategy to migrate the ecosystem towards that mechanism.
Yeah, usual. Right, so now let's get to this. Opening for review the browser API. So in the previous demo that we saw, the focus was more on this one device, three device. The real question, how does a request look like when the verifier does the call to the browser API? So that's kind of addresses that part. And thinking was, we've been working on a verifier here for like over 3 years now, and we've been gathering a lot of implementation feedback to implement this ecosystem. So combining kind of the best of both worlds is really the goal here. And the problem we're trying to solve is first custom URL schemes. So I think problem IW is that we heard concern from the operating the browser vendors saying that custom URL schemes are not secure. Basically, it's not a good UX because one platform behavior is unspecified, another platform it doesn't really give a good option for the user to choose the wallet. If there are multiple wallets on the user's device, it can handle the same request. So it's not really a fair play among the wallets on the device. But also anyone can register, any wallet can register the custom URL scheme. So even if an attacker's wallet could register, so that's kind of feeding in. like there was I would say, agreement among both the Brain for VP people, browser people, that we should be moving away from custom URL schemes. So that's, the first point we're trying to address. Second point, we already touched upon it, but cross-device flow. So we did do a security analysis. The University of Stuttgart did security analysis of OpenID for VC flows. And basically the outcome was, under the assumptions made, the protocol's flow is secure. And those assumption is the cross-device flow was basically one of them. So the phishing attack that we already talked about, where phishing becomes possible because verifier can't make sure that the response session belongs to the same user session as the request. So solving that is another, basically two big motivations. And then there are a few other motivations where the UX, where with the redirect after the post, for example, when you're doing things directly between the wallet and the verifier, there's not always a guarantee that the user will end up in the same browser. So, but with the browser API, the wallet will, as the verifier will get the response directly from the browser API. So, you're in the same browser phrase. That's another piece of it. And the last piece is the origin becoming another kind of security information piece that wallet can use. So if
Just
thank you. Yeah, I thought maybe it was I go blank and I was about to say. Right, yeah. So basically, if verifier can send verifier's intended origin, and the browser is also sending the origin available to the browser, and wallet compares it, it potentially prevents the replay of the request, right? Like that's the last piece. Then you want
We will come to that.
Yeah, come to that.
I mean, have you added the new
I did,
flavors?
yeah.
Okay, cool.
So that's inherently one of the things that we get over custom schemes as well, is that the intent for a custom scheme that goes from a browser to a native app, there's no context about the caller, really, provided by the platform. And the web platform API obviously dramatically improves that, just like how Web Authn works. The browser can actually say, well, this is the origin that's running, and this is the origin that's invoked this API, and there's also a big improvement at that front end of that flow when the wallet receives the request.
And additional, what is this request all about, right?
Exactly.
What credentials, what data, and all that stuff. So it's really it's a really, really sophisticated custom scheme, right?
I don't think they'll like that brain. They'll put a very sophisticated custom URL scheme.
That's the name institution feature on Android. Really, really sophisticated.
Yeah, basically, for example, like in European Union right now, opening for VP is, part of the implementing and part of the requirement, the law, and they're, for example, starting beginning of May, there were 100 implementers building it. And it took us honestly a lot of effort and time to educate all the implementers, like what is needed, why, because there's this mental model shift, right, from the existing federation model to like this new wallet-centric model. But these problems do exist. So yeah, super grateful for Jose and her collaboration and involvement to try to address this.
I would like to shed some light on my metaphor, right? So don't get me wrong, I do not want to offend you, but in the end, it's an invocation mechanism. It's a very privacy-preserving, very convenient invocation mechanism. But as we already have seen in the session before, the true user consent and all that stuff is happening at the wallet. The demo didn't show that, because the demo just in the wallet more or less asked for the fingerprint or the whatever. But basically, and I think the terminology right now is what you do with the browser API as the permission, but the user consent actually then happens in the wallet, because the wallet then authenticates the relying party and knows in what trust management or trust ecosystem, trust framework it's operating on, and all that stuff. So there's a lot of things that need to be done, right? And so from that's the position I took when I started to design the profile, right? We have the custom scheme right now. I can send a very privacy-preserving request because I don't know what wallet is going to answer that question. And Sam somewhere, where's Sam? There's Sam. Sam opened my eyes when he asked me, do you really want to reveal to the verifier what wallet it's talking to? And this is me. Was it? Okay, so Sam and Lee. Thank you very much.
Thank you, Lee.
So in the position, No, no, let me explain. So the position I took is, I mean, if I use a custom scheme, what I do, I send a request in a tunnel, and what comes back is the result. I don't need to know who generated that result. And that's the same perspective we are taking here for the browser API, right? So, and then with that, back to you, Christina.
Thank you. Yeah, I mentioned here is Tim's favorite diagram to illustrate who has what responsibility. So basically, verifier, this is the front end JavaScript running in the browser, verifier backend, is basically, particular to the verifier. And what we're talking about today is the step 2 and 7, where verifier sends the request to the browser API provided by the browser, and then how that gets communicated to the platform API and back to the native app is out of scope of what we're talking here. It's partial, not partial. It was covered by the demo we saw in the previous sessions. This is more on the state tab world in Fido. So yeah, just to illustrate that. And so this is a specific proposal, how it could look like. This is a basic example of what I call unsigned request, but basically where the origin that we mentioned before, origin provided by the verifier matching the origin provided by the browser is good enough for the wallet to establish trust and identify the verifier. Like that, this is kind of the minimum scenario, right? So so in the previous session, if you were there, we saw 2 parameters, protocol and the request. Here we're showing you specific values. For the protocol, we're saying the OpenID for BP protocol is being used. And this is a specific request. There's some discussions here, but
This is syntactically no longer correct because that now is a JSON object, so we can we can remove the JSON stringify.
Okay. So yeah, so client ID identifying the verifier, which I think should is the source of the origin.
Don't get hung up on those details. I mean,
well, let's say this is source of an origin. That's
Yeah.
all it's going to compare. This is a new client ID scheme web origin indicating like you have to compare this origin with what you're going to get from the browser, and then the standard parameters. The most important is I think some nonce to prevent replay of the credentials being returned, then client metadata where you can pass the public key of the verifier that the wallet will encrypt the response to, and then implementation definition, a definition specifying what credentials being requested, which would be used to render that consent, not the permission screen where user selects the wallet and the credential. All right.
so fundamentally, you can throw any OpenID for BP request into the API. So that's the way it is designed. Just get rid of the custom scheme and use the same request. It's not rendered as a URI query parameter or as a set of URI query parameter. Instead, we just put it in a JSON object as you would do it in a signed request. That's basically what we did, right? No modification in the end to OpenID for BP. We just introduced a new client ID scheme.
Somebody new again to this. When's the client ID different from the client ID different from the origin of the RP?
That's the next, the find request option. We'll cover it on. So I think the previous question, the previous session. So if you're trying to specify the format of the credential, MDOC versus DJAR, for example, like you would do it in the implementation definition, just like you do normally right now. So the wallet would receive the protocol value of VP, the content of a request. You want to talk about this?
Yeah, basically, I mean, as Tim pointed out, this part is not in scope for the YCG. So there is no standard right now for that. That's platform specific. However, this is the assumption that we are operating under, that whatever operating system it is, that those are the 3 pieces of information that are provided for the wallet. Might be different from an API design standpoint, but those are the 3 information you get. So, I mean, you obviously need protocol and request, but what is very valuable, you also get the authenticated or asserted origin from the platform. And that's the new quality here.
Working is
We send it for you.
so the details of how basically, for example, this new client ID scheme, whatnot, that would be specified in the annex of the neighborhood communication protocol normatively, but all the intricacies of, like, how does this structure look like user navigator.identity.get, for example, that would be specified in the WCC. There's a working group being formed right now. So that's kind of the separation of responsibility we're trying to do, like leave what browsers know better to the browsers, and what's way for VP people already know, just do it in the Open Foundation. Yeah. So in the response, software wallet validates the request. Wallet prepares VP token. May must. There's still discussion. Encrypt the response. And the wallet receives. This is the new part, right? Wallet receives the response directly from the browser API, not from the wallet, but from the browser. And the verifier performs usual processing of the credentials. So that part, you should be able to reuse your existing code. Now, so that was the basic part, right? Now this relates to the question that Marcus asked. For example, in European Union, like legislation literally says the origin is not sufficient to authenticate and establish trust in the verifier. So this is from here trying to show how that could look like, where, for example, there's a trust chain using X509 certs or OpenID federation, establishing whatnot. So this is where the request is signed. So the previous example was the JSON object, and here it's signed. And the verifier uses external trust establishing mechanism to establish trust. So basically, the wallet validates the signature and be able to trace back to the root of trust to be able to establish trust. And to do that, yeah, well, you would have to have access to, the root certificate or the trust chain. Thank you, whatnot. Yeah. So this is the assumption, the requirement, the context we're operating on from here. And then this is the discussion we've been having, how the replay of the request being prevented. So the context here is basically in usual OAuth, when the request is signed, because the response goes directly from the wallet to the verifier, where the credential ends up is in integrity protected signed request, right? So even if I replay that as an attacker, I can't steal the credential itself because it's going to be sent to an endpoint which is integrity protected, to the endpoint that belongs to legitimate verifier whose request I'm replaying. Well, in the browser, because the browser is pretty much already man in the middle, right? In a good way. That verifier is receiving the request from the browser. So it's possible to replay that request basically, right? Like if Tobias generates the signed request, I send it to the browser, and the wallet just validate, wallet knows how to establish trust in Tobias. Thank you. But I, as an attacker, will still get the response back from the browser, right? So how to prevent that replay was, what we found out. And right now the thinking is the signed request would contain the verifier's origin, and the browser will have, so that origin gets integrity protected, right? And the browser will have the origin, so that the integrity protected origin will be matched with the browser provided origin, and that's how you know that if you trust the browser, which you should, you would be able to establish to prevent replay. That's the current thinking.
Yeah, to shed a bit more light on the history of that feature. So the first design, instead of, I think John, you brought that up, right? So thanks a lot for that proposal.
So Dirk and I spent a lot of time thinking about this, and I know Dirk actually probably wants to do a specific presentation. His idea.
Okay, I just want to. Okay. Okay, then just let me shed some light on the history. So when we started that, first of all, I studied the IDAS regulation to figure out what we need to do, and there is explicitly being said that the member states need to maintain a trust management system, which is outside of the Web API. So we need to figure out how to support that, and that using a side request is obviously a solution for that, but you need to replay protect it. And the first design proposal I made was to use a wallet provided nonce, because that's considered best practice, right? The recipient of the signed request provides the challenge. And that had a couple of implications and caused a lot of discussions, because what we used was the HTTP post mechanism that Christina explained before, which meant after the selection of the wallet would have sent a direct request to the verifier, right? So, and there are a couple of reasons why this is not a super duper solution, right? So it's complex from an architecture standpoint, and there are privacy issues being discussed and so on. And Tobias also pointed out there is still the opportunity to man in the middle there. So, and that's why we came to the conclusion to use the I would say the claimed origin that is signed in the request, because then you can use the external trust management. First of all, validate a signature, establish trust in that, and then trust in this asserted region and compare it to whatever the platform provides. So that's the current thinking. We're not super convinced that it really cops with all the threats. So we still need to do a in-depth security analysis of that, as we always do. Yeah. So that's the current status of this thing.
So, having thought about this a fair amount, so we have to deal with both the trust establishment with the wallet, and we want to also prevent the selector from sending people down dead end. So ideally, we want, well,
That's
at least I would like the selector
that's
to,
difficult.
I would like the selector to have the appropriate information to only send the user to a wallet that can actually suffice. So we could put the origin, the web origin in the signed request, and I don't have anything against that particularly, but and the selector can compare, is the origin the same as the one that I'm being passed by the browser, and that works. The other alternative is allowing the selector to return the well known metadata by having, so you need a key.
Upon
So you need to,
not well known upon what party?
from the RPID. The RPID resolve the metadata for the verifier, which would tell you what signing key you expect the signed request to actually have.
Which does not establish trust. It just tells you just a signing key that you can use.
Well,
the trust establishment is the next step then.
Well, it does. It just allows with PKI, because the browser would resolve the well-known, like if you had a well-known file on the reliant party, it would resolve.
Okay, then we are on that PKI again. We don't.
Well,
we
but-
are doing this to not rely on the
Okay,
PKI.
but I'm often saying that we need, it may be an okay compromise to rely on web PKI for the selector, not for the wallet. So I think that we can say, yes, this isn't perfect. The wallet can be perfect, but the selector can do a pretty good job of making sure, unless the RP is really malicious and goes to a lot of trouble, it will work.
So the problem you wanna, what problem do you wanna solve? You
So
wanna really validate the signature of the request?
I want to, well, I think that we could actually do it without necessarily signing the request if you put the known or the acceptable in the RP's metadata. It said these are the origins I'm going to send requests from.
Yeah.
Then you would get the origin, you reference the origin, or get the RPID, you reference the RPID from its known trusted web source. Look at the list of.
I don't think you can get rid of the signature.
Well, right.
So my work, like we talked about it last night. I think there's a person in the class. On top of just
Right.
I started getting the verifier because those things really protect the browser parameters. And if you don't sign it, the only place to detect
Right.
someone malicious is
So,
to get
I'm not against signing. I'm not against signing the request, but there's other information in the validators metadata, such as trust marks and other things that the selectors may actually be able to use.
But then you're depending on OpenID Federation. We want to have a mechanism that is general purpose. I mean, my feeling is we should
Yeah.
I mean, Joseph also already said we should perhaps put that
Should
offline.
be-
I mean, I think first of all, I think the signature of the request is an absolutely reasonable step to let the wallet authenticate the relying party. Anything we need to do beyond that to improve the user experience, let's talk about.
So when we talk about so I'm imagining that some government or somebody like interested in this conversation, not explicit, which is my following. It's like how do we imagine this is being said? The example how is the example of things like origin is being named? You just- The way the government says this example RP is allowed to do XYZ.
Why doesn't
it says that is oh, the holder of this certificate and the holder of this.
Why does that matter? Why does that matter?
Because it matters for
So- So my argument is that we have a logical model of, we have names for verifiers, i.e. RPIDs, and RPIDs may have multiple web origins because the German government may have multiple sites that can ask for the same credential. So we have, in OpenID, we have this logical model of, yes, we have a client ID, RPID, whatever we want to call it. We have a logical identifier and we hang things off of that, including resolving metadata. On the web end side, the sort of the browser outlook is everything is based on what is the web origin of the page that I'm talking to. So in the W3C work group, the tendency is to think, yes, I'm going to build all of the security based on the origin and the name of the origin, which means that I would then need to go get metadata from that origin, each origin separately, et cetera. So we just have a different logical model of how things are named.
I understand that.
So I think that's what Dirk and I are.
And I think the difference between the different mechanisms is you can have metadata that more or less establish the relationship between the logical ID and the region.
Right.
Statically, more or less. So you need to configure that, or you just put it in the request. Signing. Let me conclude. So signing the. I thought about that also a lot. So signing over the region in the request is essentially the same as just using any arbitrary redirect UI and part, because you in the end can establish a trust based on the cryptography, right? So and that is much more dynamic and easier to manage than setting up metadata that need to be maintained if you, for example, roll out a new app and all that stuff. But having said that, that's a detailed discussion.
Right.
Let's have it in a different place.
So let's park it here. Bottom line, the problem is there. We need to prevent the replay of this kind of request. But
I think we are over
you've
that.
heard your shift.
We're not trying to optimize it.
Sorry?
I think we already are over that. We are now trying to optimize it.
Yeah. So is it related to that? Or?
It was related to that. I was just gonna say that one does not prevent the other. You can still have, like, if you do have those with data coming from the verifier, you have your origin signed somewhere, and the origin coming from the browser, you can still that comparison do it. And
So I completely agree with that. The part of the question was, should we remove the RPID from the API call because some people like reducing the number of parameters? And I was arguing, no, we don't want to get rid of the RPID.
Good, very good.
I think there are places where we can get rid of it and we should do it.
Yeah.
It just let's do reasonable decisions, right?
Right.
But
So I'm not saying never, but the protocol sort of.
I can also give a concrete example, John. So what do you think about continuing the presentation? We have a concrete example of an externally managed ID, and you will see you like it. I guess you like it.
We've had that discussion and we think we
Current-
probably don't, but we need to do the full security
So-
analysis.
John and Daniel think it's okay.
I still think that that the verifier should, in its request, have a challenge nonce that winds up getting signed. But this isn't the meeting to sort that out.
They're fine, but they're struggling to follow what's happening here. What I'm wondering, the question I have is this a new problem? Is this a problem that is introduced only because of the browser API?
Yes.
Well, why is it, how do you
You're
solve
sending
this
a
with
request and
custom scheme? Why don't you have this problem with custom schemes?
Yeah, that's the custom scheme, so just to explain, in VP, because response is sent direct wallet to the verifier,
to an
right?
authenticated endpoint.
So that endpoint, the response gets sent, is integrity protected by the signed request. So if Tobias signs over his own endpoint with his keys, and I steal that and I send to the wallet, in usual affinity for VP, as an attacker, I won't get the response because response will get sent to Tobias's endpoint, which is integrity protected, right? In the browser, if I replay that request, will we be able to validate the signature and everything, but response to me, who sends the browser API as an attacker, gets returned from the browser.
That's if the wallet doesn't validate the origin provider as well, right? So it's trying to mitigate this situation where an attacker with maybe a compromised origin or a malicious origin tries to take a request and play it through and get the wallet to spit it back a response. And if the response happens to be not encrypted, then that's bad. But if the response is always
Even if it's encrypted, it's privacy.
yeah, you still leak the credential, right? You still leak the presence of the credential. So it's more the fact that like an open VP with the direct post model goes directly to the server that is trusted.
Okay, time check, we have
Mark.
But generally, having worked on browser APIs for, over 20 years, generally the way that we do this on the W3C side is come with a problem statement, which is nice that you have, and then we try to come up with a set of solutions. It just feels like there's going to be resistance from the browser side because it's not something that we're participating in and taking part in the discussion on. So it's nice to have a very concrete problem that we can try to solve together. And the solution may be that, yes, we need client ID, but it's nice to land at that solution together. So it's just like, with all the things that are being proposed, it doesn't feel good to like have them imposed on the browser. It's more like, hey, let's go through each individual one by one, see if each one makes sense, and then we should add them. So I think that would be a very productive approach.
Absolutely, fair point. So just for everyone who might be confused, if you're confused, forget about what you heard. Bottom line, what's happening is there's a regulation in the EU that requires trust management. It does not rely on API. That's requirement number one. We have to realize that. Requirement number two, if the request is signed, there is this new problem introduced with the browser API that it's possible to replay the signed request, so we need to solve it. So bottom line, I think those are 2 points we're talking about, and we have to agree on the commonly everyone's happy solution.
And on the meta level, we have 2 communities starting to work with each other. So we have to get to know each other and then tune into how does it work on the web API side, how does it work on but we are making good progress on that. So
Yeah, and then, we're making good progress. So, and to add to that, the third requirement is, so as we said, when verifiers comment in the request, whether it's a browser API or user paying for VP, there are cases when it doesn't know the capabilities of the wallet, right? So we have to make sure. So in direct wallet to verifier paying for VP, we're trying to solve it with this response URI method post that we talked before this conversation. But in the browser, we have to solve it too. From the conversation we had yesterday, I think it's solved by basically this is an array, so you can pass multiple requests. So you can, for example, say send one request with ability federation, one request with just 6509 in case wallet understands only 6509, for example, right? So that's kind of the third requirement and the potential solution. So this is when the requirement of this external trust framework is addressed. So same protocol, the string is it's obeying for VP request, then like this will be signed, so it's going to be a JWS. But client ID scheme, in this case, example is entity ID, so an ID federation that first alluded to, and the rest is the same as you saw in the previous request. nonce, kind of metadata, potentially including the encryption key, and the implementation definition. And as I said, it's an array. Yeah, so it's the request to be a string. It's AWS. It's 3 dots separated, so it's not exactly the most correct example.
Yeah, so
Sorry.
Christina was trying to cheat. Yeah? So what you basically have is
Okay.
no, to make it more convenient for the readers. So you've got a client ID, you get a client ID scheme, and then you've got another request parameter. That request parameter is a JWT, and the JWT contains all the actual other parameters. This is standard RC 9109.
Yeah, I don't know if they want that.
I think that we
Yeah.
don't need
You
to-
got 5 minutes.
Yeah. Okay, so
Q-
data
Q&A?
response, again, what validates the request? The signature establishes trust and verifies that this is right, prepares CP, token, credentials, certain A or must encrypt the response. Again, there's one additional going. The verifier receives response directly from the browser API. It can perform standard processing, noise, audience, cryptographic clear, whatnot, and everyone's happy. It's like,
So what if redirect URI? That's part of standard request and it's irrelevant to the browser.
That it wasn't on the example.
I saw that.
Yeah.
Are you,
Deliberately.
is the intent to just omit it?
Yeah.
You can have a look. I did a pull request on that. That in the end adds an annex to the VP specification, and it basically says you can use any request except the redirect, any parameter except the redirect URI, and if the redirect URI turns up, the wallet has to omit it or ignore it. I mean, it doesn't make sense. Yeah.
That's fine.
But all the other parameters from my perspective might make sense, so we didn't rule them out yet.
I agree. I just wanted to surface that here.
Yeah. No, it's not the origin. It's the entity ID of the relying party calling.
For example, or, but if the origin is calling from some other origin, there's some check.
So they
All
have,
origins allowed to a certain.
I think we need to define a separate parameter to talk about the intended origin. So that you're not forcing the verifier's front end domain to be the same as this, because it doesn't have to be. So it's,
Right.
so if it's not here yet, I think we have to define something here.
So they're not, it's the idea that they're not the same.
You have to
You
establish
have to show
relationship.
your work to explain why I'm allowed to.
Yeah.
You have to be able to build a relationship, otherwise
Yeah.
you want to be able to validate that the origin that the browser sent the request from is somehow related to the entity ID that's requested.
I mean, basically, if you also think about platforms, and that's the reason why I thanked Lee for the statement that I cited. If the call is not done through the browser API, but through Android, for example, the region, as far as I understand, is different. But nevertheless, we have to somehow create a relationship between the origin and this entity ID. So whatever the claimed origin will be, it's a string. It's a string that the wallet needs to compare with whatever string is provided by the operating system.
As long
So
as
could
it's
also
I think it's good, right?
Yeah.
Package ID.
In the end, it's could be a package ID as well.
Yeah.
Yeah,
Yeah.
absolutely. You can use any client ID scheme that we have.
Theoretically, you can even use
How does it work?
that one.
Calling origins.
Yeah.
Can I ask a question about profiles?
Yeah. Okay.
So just big picture, how is one thinking about profiling the different options? So if you're an issuing authority, does one have to think about how it's profiled or different profiles in different jurisdictions? How would interoperate, or is there one common way of implementing?
Yeah. So
I think that's not related to browser.
profiling would happen in your VP world. We already kind of.
But separate to this
So that's
implementation?
why I've been pushing to put the format, the profile identifier here, because you need to know what profile you're talking about. But yeah.
Okay, so it's another conversation.
All right. No? Everyone, but. All right, thank you so much for being here.
Thank you.